4.3, writing equations of parallel and perpendicular lines. So starting out, parallel. If we remember parallel are lines that never intersect, which means they never touch. So if we look at them like on a picture, if one line was kind of traveling in this direction, then the other line would be down here somewhere traveling in the same direction. In geometry, the way that you show parallel lines is you give them the same little arrow marking, meaning they're never going to touch each other, they're never going to run into each other. Now, what this means graphically, so parallel lines and slope, is that they have the same exact slope. So if the first line here has a slope of 1/4, that means the second line here also has a slope of 1/4. So if this guy rises 1 and runs 4, then this guy rises 1 and runs 4. They're exactly the same thing. Example 1, line A passes through the points -5, 3 and -6, 1. Line B passes through the points 3, -2 and 2, -7. Are the lines parallel? Explain. Now, if the lines are parallel, like I said, that means they have to have the same exact slope. So, game plan here, find the slope of line A, find the slope of line B. If they're the same, they're parallel. If they're not the same, then they're not parallel. So, on the left, I'm going to start with line A, and then on the right, I'm going to start with line B. So for line A, m equals the change in y over the change in x. So here's my y value, here's my y value, 1 minus 3 over, here's my x value, here's my x value, -6 minus -5, and be careful with your negatives. 1 minus 3 is -2. -6 minus negative, remember that's going to flip to a positive and be -1. And then -2 over -1 is +2. Line B. So m equals the change in y over the change in x. So here's my y value, here's my y value, -7 minus -2. And again, be careful of those negatives. 2 and 3, 2 minus 3. -7 minus -2 is going to be -5. And then 2 minus 3 is -1, which ultimately is going to give us 5. So my first line has a slope of 2. My second line has a slope of 5. Are they exactly the same? No. So are the lines parallel? I would say no, they do not have the same slope. And in fact, if we were to look at these graphically, a slope of 2 rises probably at a pace, I don't know, maybe like that, versus a slope of 5, which is greater, has a greater rate of change. So he's going to rise greater. So eventually, depending on what they really look like, they would cross each other because 2 is less steep, 5 is more steep, so they're going to run into each other. Number 2, write an equation of the line that passes through -4, 2 and is parallel to the line y equals 1/4 x plus 1. Now, I'm going to start here with the fact that I have to be parallel to this line. If I have to be parallel to this line, it means I have to have the same slope. So the same slope, I'm looking at this line going, okay, well, this is the y-intercept. I don't care what the y-intercept is. I just care about the slope. That's right here. So my slope has to be 1/4. And then as for the rest of that line, I don't really care about it, because I know my equation of a different line has to pass through this point. So I have a point and I have a slope, which means I'm going to go back to my point slope form, which is y minus y1 equals m times x minus x1. Y minus, here's my y value, 2 equals my slope, 1/4, times x minus my x value, -4. Then we're going to clean that up a little bit. Y minus 2 equals 1/4. For right now, I'm going to leave the parentheses because I'm only going to clean this up and make it x plus 4. Now, if I go back up, it just says write an equation of the line. It didn't say in what form I had to write it, so quite frankly, just leave it like that. That is the equation of a line that passes through the point -4, 2. So you always do the opposite. So -4, +2, with the slope parallel to 1/4, which is the same slope right there. You're done.